myself Dr. Manoj Kumar, working as an assistant professor in Department of PC at MLR Institute of Technology, Hyderabad. Today I am going to deliver a lecture talk on performance characteristics of an instrument. So basically, what are performance characteristics? Performance characteristics are nothing but it defines how accurately and reliably an instrument measures, monitors or controls the physical quantity. So performance characteristics will measure the performance. It will measure the performance in terms of what? It will measure the performance of an instrument in terms of accuracy, its control. So these are some of the parameters based on what we will judge a performance of an instrument. That's why it is very necessary to study about the performance characteristics. Why they are important? They are important to ensure high quality of measurement. It enables proper instrument selection for specific application, and it also helps in identifying the limitations of an instrument. So basically, if we discuss about the performance characteristics, it will measure the performance based on its accuracy, based on its reliability, based on its control of the physical quantity. So these are parameters based on what we will judge the instrument whether it is performing okay or not. So it is very important for any instrument. Classification. Actually, performance characteristics has been classified under static and dynamic. The word static means the performance measured under steady state condition, that is called static characteristics. If the performance of an instrument is measured under the changing input condition, will be termed as dynamic characteristics. So both characteristics are very important. So static characteristics means the performance of an instrument measured under steady state condition, and dynamic characteristics means performance measured under changing input condition. So these two things we will take in detail. So under static characteristics, we will see accuracy, precision, sensitivity, linearity, range of an instrument, resolution of an instrument, everything we will discuss in detail. In dynamic, we will see the response type of an instrument. Then we will see the fidelity of an instrument, dynamic error, and speed of response. These are some of the parameters under the dynamic characteristics, and these parameters are under static characteristics. So in order to judge the performance of an instrument, we have to analyze both static as well as dynamic characteristics. Then only we can decide whether an instrument is reliable or not for working. Here we will see the key element for performance evaluation. So first is that input source. It provides the physical quantity to be measured. Then measurement device, instrument or sensor to capture the data. Then we will have the standard reference, benchmark for calibration and comparison. Then we will also have to consider the environmental consideration. What is the effect of temperature, pressure and humidity on the performance of an instrument? So these are some of the key elements for performance evaluation. So first of all, we would like to see the static characteristics. Already I discussed. The performance characteristics of an instrument can be categorized under static and dynamic. Static consists of finding the accuracy of an instrument, how much the measurement is close to the exact value, that is called accuracy, the degree of closeness of the measured value with respect to the standard or exact value, that is called accuracy. Precision. Precision means repeatability of measuring instrument. Suppose if we are measuring something and we are repeating the same process again, and we are getting the same value, means it is 100% precise. The instrument is 100% precise. That's it is the meaning of precision. Sensitivity, the output change with respect to input, that is sensitivity. Linearity, this is very important parameter, linearity of an instrument. As already I discussed in previous lectures, that linearity of an instrument is very essential. Why? Linearity denotes that there should be a linear relationship between input and output change. If it is varying non-linear, then it is very difficult to predict the behavior of an instrument. Range. What is the working range? Whether it may be frequency range or some other parameter range. Resolution. Resolution is nothing but the smallest input that can be detected by an instrument. That is, that all parameter will come under the static characteristics. Whenever we will purchase any instrument, we will find all these parameters in the data sheet. By observing the data sheet of an instrument, we can easily find what is the accuracy of an instrument, precision, sensitivity, linearity, range, resolution, etc. So all these parameters of an instrument will be given in data sheet. So before purchasing any equipment, we have to go through the data sheet to have the overview of its static characteristics. If it is okay and it is within your working limit, then you can go for the purchase of that instrument based on the static characteristics. Already I told what is under static characteristics. What is accuracy? The closeness to the true value, that will be accuracy. Precision, the consistency in repeated measurement. Sensitivity, the instrument's ability to detect the small input, that is called sensitivity of an instrument. Linearity, already I discussed. Proportional between input and output, that is called linearity. Ideal case, it should be a straight line. If it is straight line, that means that instrument is perfectly linear and it will give the accurate result. Range, the maximum and minimum value that instrument can measure. Resolution, already I discussed, this is the smallest change in input that instrument can detect. Repeatability means the consistency of an instrument to be measured under the same condition. So these are some of the parameters under static characteristics. Dynamic characteristics. Already I told dynamic characteristics when it will be non-steady condition. The measurement of an instrument under non-steady condition, that will be a dynamic characteristics. Already we know whenever we switch on any appliances, it does not go immediately to the steady condition. First it will rise slowly, then it will get settled down to the steady condition. So before getting steady condition, it has to undergo non-steady condition, which is also called dynamic behavior of an instrument. Suppose when we switch on the fan, it does not go to the high speed at a moment. It goes slowly and then reach the high speed. Like that, any instrument, whenever it is switched on, it first show the dynamic behavior for some time. After some time, it gets settled down. That settled down performance will come under static characteristics, and this will come under dynamic characteristics. Under dynamic characteristics, we will study about the speed of response. Then we'll have fidelity. Then we have lag. Finally, dynamic error. These all parameters we will study one by one. Dynamic characteristics, speed of response. The time taken to respond an input change is called speed of response. The speed of response of an instrument should be very high. Then for a good instrument, the speed of response should be very high. Fidelity, ability to reproduce the input signal without a distortion. So fidelity of an instrument is very important to study. As we know that any electronic component has some parasitic resistance, parasitic capacitance, this important term, parasitic capacitance or parasitic resistance, which causes the distortion of a signal. So we can't eliminate to the 0%, but we can minimize by optimizing the circuit design and etc. things. So fidelity is the ability to reproduce the input signal without distortion. So here we have to understand how the distortion is caused by the instrument. So distortion of an instrument is basically caused by its parasitic capacitance or resistance inside the circuitry. Every circuit has some parasitic resistance and capacitance. Lag. Third and important parameter is lag. The time delay between input application and response. So there is a time delay in any, suppose if you are giving the input at time t equal to 0, it will take some time to reach the desired node point. Why this is happening? This is also happening due to these parasitic elements, because suppose in any circuitry we have to assume that there is some parasitic capacitance and resistance. So whenever you give some input signal, this capacitor will try to block the input and it will slowly show the rise of the signal. So delay is due to the parasitic capacitance. Dynamic error. Difference between the true and measured value under the dynamic condition. Already I discussed. If you are measuring the error, suppose this is the true value, and if you are measuring this error, it will come under dynamic condition. Factor affecting the performance of an instrument. So we have, what are the factors that affects the performance of an instrument? We have environmental factor, which consist of temperature, humidity, vibrations, etc. Then we have instrument design, quality of component, calibrations. Then we have operator skill, how to proper handling and interpretation is very important. External interference, electromagnetic or mechanical noise. These all 4 parameters will affect the performance of an instrument. Performance characteristics in action. So we will take some example. Suppose thermometer. Accuracy in measuring the body temperature. Dynamic characteristics in its speed of response to sudden change in temperature changes. So this one, from this example, we will try to understand what is static characteristics and dynamic characteristics. Static means it will show the accuracy in measuring the temperature. That is the characteristics of thermometer. We are purchasing thermometer to indicate the temperature. So how much accurately it is showing, that will come under static characteristics. And suppose the temperature of body suddenly changes, and accordingly our display should also get updated. So speed of response will come under dynamic characteristics. Like that, digital multimeter. So static characteristics will be precision in measuring voltage. Dynamic will be fidelity when measuring the fluctuating signals. So in multimeter also we will try to understand 2 cases. First is static characteristics, which will show the precision in measuring the voltage, and second is dynamic characteristics, which show the fidelity when measuring the fluctuating signal. Dynamic always indicates some fluctuating signal or change in input. Okay, these all will come under dynamic characteristics. Application. So already I told that performance characteristics is very important, and it ensures the accurate control of machineries and process. It ensures the reliable data acquisition for experiments. It ensures high precision monitoring of vital signs. It ensures the performance monitoring under the extreme condition. Ensures the reliability of device like thermometer, smart sensor, etc. So this was an overview on the performance characteristics of an instrument. Thank you.